this is going to look a little strange because I have assignment 2 and assignment 3 in the same place, so I'm going to have to deal with some compiling issues. But this is a video for assignment 2, and there'll be another video for assignment 3. So we'll ignore the assignment 3 stuff for now. And look at what we have to do. So I need to make 3 classes: integer accumulator, memory data store, and string accumulator. So I'm going to start with a memory, because why not? And it is confused about something, but I don't actually know what. Oh, no, I just did the wrong thing. So I do want to look at the data store, because I'm going to implement that, and it takes a parameter. So as you know, I like to make everything final, so I'm going to go through and fix those up. It just prevents me from accidentally changing things, which means that I can't make mistakes. The other thing I might do is just, for now, throw new error. That just means that I can't forget to implement this. It'll just work. It can compile. If I forget to implement it, it won't happen to return a sane value. It'll cause it to crash. So I know what I have to implement. And if I look at main, I see that there's an memory data store that's parameterized. And the integer and the string accumulator do not take parameters, but the accumulator does. And through some detective work, namely this, I can tell that the function that it takes, if we look at the accumulator, it takes a function which has a from and a to, basically. This takes the value and just returns the value, therefore the from and to are the same. So I'm going to make a new string accumulator. Accumulator helps if you spell things right. And is going to implement the accumulator for string and string. So all I'm trying to do right now is get the thing to compile. That's my most important thing to begin with. And I also want to take the string accumulator and paste it here and call it an integer accumulator. And I need a constructor that takes 2 ints. So this will not fully work because we don't have the assignment 3 stuff. So what I'm going to do just for now, so it will compile, is copy these 3 files over to the assignment 3. You wouldn't have to do this normally, but I just wound up with these in the same folder. So And that is the power of packages. You can have two packages with the exact same classes in them, but they do different things. I'm slightly confused. I think it might be because it's importing the assignment 2 versions. So that's one thing to check when you're doing stuff. Okay, so it builds, that's good. Now I can ignore assignment 3 for now and just go to assignment 2. Nothing's going to work without the memory data store because the integer accumulator and string accumulator tests use the memory data store. So we have to get that working first, or at least limping along. So let's run that test and see what's wrong. Everything will be wrong. So the first thing is we don't have a constructor. I mean, we have it, but it didn't do anything. And I'm thinking in terms of Excel, right? And Excel has rows and columns and all that, so I could use a list. But a list is not something I particularly want to use. I could use an array of arrays as well. That's possible as well, but creating an array of generic things is annoying. So I'm going to actually use a map. The map has integers for the key and integers. The map is integers for a key and another map of integers for the row and the value. So I could have done this entries thing inside of the constructor. I don't though, because this line here does not depend on anything in the constructor, so that's why I keep them separate. But that's my own choice. You can do what you want. So now I have to loop through for each of the rows, and then for each row I need to go through each column. When you're copying and pasting, make sure you don't miss any of those things. These are all col, these are all row. Quite often you do something like leave this as row, and that'll cause you nothing, or rows, that'll cause you nothing but problems. And for each row, I'm going to make a map for that row, for each of the columns. Okay? And then what I'm going to do is I'm going to, for the row entries, I'm going to put the column and null. So I'm just going to make sure null is set for all of those. And then I'm going to, in the entries, put the row for those entries. So think of this as a huge checkerboard, right? These are the rows, and each row has a set of columns on it, right? So here we're putting the columns. These are the individual squares for one row. And then we have to put that row on the chessboard or checkers board, whatever, and then move on to the next row and keep doing that. So if we made an 8x8, right, passing 8 rows, 8 columns, we'd have 64 things all set to null in groups of 8. So there's your constructor. To set the value at, we can actually steal some of this code. So we're going from the entries, we're going to get the row that was specified, and I'm ignoring the fact that they could be specifying invalid rows at this point in time. So we can get the row that they wanted, and then for that column, we're going to put the value that they passed in. And get at is really similar. We're just going to call get here. And the get the number of rows is quite simple, where we can do okay, get the key set, which tells us how many keys are in there. There's one key per row. And because all of our rows are exactly the same, we just need to do something quite similar to this. Not exactly the same. We have to have at least one row in it, so row 0. And the size for that. So that's hopefully right for some things. So nothing crashed, that's good. The problem is that we're not dealing with the cases where things are outside the range. So we're supposed to be throwing in a legal argument exception when things are too low or too high. So in the constructor, if the rows is less than 0, we'll throw in a legal argument exception. If the calls is less than 0, right? We can't have the rows are called actually less than or equal to, so it's less than 1. You have to have at least one row and one column. Right? You can't have an Excel spreadsheet with no entries in it. Same kind of thing here. If the row is less than get rows is greater than get rows, or the row is less than 0. And we could have variables in here for the number of rows and number of columns. We could have saved those off. That's another way to do it. I prefer to use the entries because if the table size changes for some reason, then I don't have to worry about it. But both ways are valid. This way is a little slower. The other one where it saves the values in instance variables is better. So the problem now is that I don't have the right message. And it's presumably going to be the same thing for the call. Yes, I know that didn't work yet, but I'm working my way to it. looks like I've just got a slight logic error. So if the call is less than 0, so if we only have one column, I think this needs to be greater than or equal to. That's a very common mistake to have off by 1. Call 1 does not exist, but what is called 0 does not exist. Nope. See? Made a mistake there. Right, copy paste. Screws you up. But that's why we test all those things. Right, so our memory data store is done. Yay. So now let's run the integer test. That's a little easier. And it doesn't work. This is not a surprise because we throw an error. So first off, I'm going to make a turn the result. So there's a basic. It won't work because again we're not doing anything add, so it'll crash here now and add, presumably. Yep. So add doesn't work. All right, what add needs to do is go through all of the rows and columns of the data store and grab the values and apply the function to them. So we're going to steal some code from our memory data store, the constructor, because it's pretty close to what we already want. Okay, so rows. I am going to make variables for these because I happen to know, but I may not know how expensive the call is. And I know the rows and columns aren't going to change in between. So it's better to save the value rather than have to call the methods repeatedly. And in the way I happen to implement it, it is quite expensive because it has to get the key set and find out the size of that. So there's one expensive call, relatively speaking. And see, when I make things final, it catches those mistakes, right? So I'm assigning rows twice, and I shouldn't be, because what I said here is, once rows is set, don't allow it to be reset. If you try to reset it, it's a bug. Well, I screwed up, I didn't copy and paste that. I don't need that, but we do need to go through all of those. Okay. Right, so now I can get the row and I can get the value at that particular row and column. I'm going through the store, each of the rows, each of the columns. So again, think of a checkerboard, chessboard, whatever. I'm going cell by cell, square by square until I grab it, or grabbing each one. And then I'm going to say function dot apply the value. Maybe change this to temp and call this value. And then I'm going to say that the result plus equals the value. Right, so this is going to call our lambda expression. So if we look at the integer accumulator test, right, it's going to do whatever's in here. Now this one, my mistake, I didn't do something like the times 2, right, which is why I had to do the assignment 3, but it'll do whatever is in this code here. So that's why we need, I'm just going to close all these. That's why we need to call that apply function. Now this won't work, but we're getting closer. So we've got a null pointer, and we got a null pointer here. So the result is not equal to null, we can add it. Sorry, if the value is not equal to null. There we go. That's passed. Now this is going to be substantially similar for the string version of it. Except these become strings. And that apply could be making it uppercase, for example. Now our result, we're going to do different than what you probably did. You probably used a string. I'm going to use what's called a string builder. It's a little more efficient. Apparently there's an emergency alert test thingy. Okay. So this just is a quicker way to append strings. You don't really need to worry about it. I keep forgetting to return there. So a string will work just fine. Okay, let's see what happens. It won't be right, but it compiles. Okay, so I'm not putting in a comma between them. So put the comma there. I'm not expecting it to work. Okay, I'm not supposed to end with a comma. So this is fancy. What it's doing is it's saying take a substring from the first character to all but the last two characters, and I might have to do -3 here, I never remember, and return that as a string. So basically we're taking the a comma space and chopping off the comma space. So let's see. Okay, that didn't work because we don't always have that many spaces. So that's bad. So what I could do is start the whole thing off with a comma space. It seems kind of silly. I could try putting the comma space first and taking it from the second character to the end. That probably also won't work if the thing is empty. Yeah. So I think I'm going to have to do as a special case. If the builder dot length equals 0, the result is assigned an empty string. Else, we do that. And this is because of the null, right? So if we look at the test, when we did this, when there's a null value or an empty value, it's still supposed to be there in the string. So that means this thing isn't working right. I'm always going to, well, actually, I'll show you. So I'm going to do two things. I'm going to flip my logic to be positive. Otherwise, I'm going to do that. So Let's see if that works, and then I'm going to clean this code up. It works. I don't like this because I've got the same line twice. So what I'm going to do is I'm going to say I always do this no matter which, right? And then I never want to have an empty if statement like this. So I'm going to switch it back to negative. Do that. So there we go. And I'm going to run all my tests for this one. Nope, not all the tests, just assignment 2. There's assignment 2 now. Assignment 2 is completed. For assignment 3, what I'm going to do, and I'm not going to solve it right now, but what I'm going to do is I'm just going to copy those source files back over. So in order to get that to work in assignment 3, what I'm going to wind up doing is just to clean it up right now. These are the ones I just copied over. They're the empty ones that were just there for it to compile. I'm going to delete those. So when we look at assignment 3, it's like we started fresh. So there we go. So assignment 3 will start with copying those over. And do not feel bad, and I feel kind of bad because I like solving these fresh. I've solved this problem like 5 times as different things came up, and I'd delete my source code and I'd have to recreate it. So I kind of, am well versed. So this last part with the cutting off 2 characters and all that, I didn't have to go searching too much because I knew how it worked. I haven't solved the assignment 3 again, so I should be a little more surprised about how to do it. I'm well versed in this one, unfortunately, which I don't like to be. Okay, that'll do for now. I will make the assignment 3 one next.